I have two papers to presentation, and this is my first paper. Is that Stable Distribution Naive Bayes achieves higher accuracy than a traditional Naive Bayes classification. So for this model, it has been many research for this. Like it will demonstrate a high computational efficiency, a strong performance in high-dimensional space. And also, it can be applied in text classification and information retrieval. And like I have so many mathematical foundation for this distribution, like focus on heavy tails and skewness. And also, we can apply in finance, signal processing, and machine learning. And then the contribution for our paper is that the first one is that we use the Naive Bayes framework, and then we incorporate the stable distribution in that, and then to customize the Naive Bayes classifier. And we also use the R-stable packages, its stable distribution functions to integrate into the Pythons for the machine learning framework. And then we also improve the accuracy for the heavy tail and skew data. And also can you apply it into the iris dataset and other 5 reward datasets to prove the accuracy. And the hypothesis for this paper is that it assumes that the stable distribution Naive Bayes model can provide higher classification accuracy than the normal distribution Naive Bayes model when the data is skewed and the sample size is small. So our experience is, first I want to introduce why we choose the iris dataset is because it conforms to the stable distribution. We can take a look at like this, the red levels and the green level, they overlap together. And yet this is very suitable for stable Naive Bayes classifier. And we also, based on the iris dataset, to generate the new datasets. Like for example, we take the sample Y example, like based on its Versicolor and Virginica's mean and variance, and then we generate these data based on the alpha, beta, and its gamma and delta, and then we convert the gammas and delta, and then we change the alpha, beta, and then we calculate the data distribution, and then generate 15 samples for each one, and then build generate the data set. And here is some experience. For example, for pendulum length, these features, we cross different combination for alpha and beta, and then we generate like 20 times experience to prove the accuracy of the stable one is higher than the normal one. Yes, and then we have these 14 combinations to do the experience. So we have to totally like 5,000 experience on here to prove that there's much more higher probability to show that the accuracy of the stable one is higher than the normal one. And then we also use some other data set, like some very common data set, like social network ADS data set. You can see that the level all overlap together, so it's very suitable for stable distribution. Like Naive Bayes data sets, like this electrical room stability simulated data sets. They all shows that the level overlap together. And like Y data sets, like we call the hotels data sets. So our methodology is that we choose the Naive Bayes model as the base one, and then we do some modifies in here to customize it as a stable Naive Bayes model. And we also integrate R function within Python because this has been introduced by Nash previously, so I'm not go details. And we use the package like stable 5.3 for the complete robust analysis. So our result shows that for the iris data sets, we can see that the best accuracy, here's the result for the iris data set. We just pick the 4 combinations here to show everyone's. Yeah, we can see that we generate different alphas and then have different beta 0.50 and minus 0.5. And now they probably largely shows that the stable one is higher than the normal one. You can also move to this graph to see that the red line is higher than the blue line. So here the best accuracy for this model is like 0.9 and 0.93 when at the combination of alpha equals to 1.9 and beta equals to 0.5. It shows that the overall performance, the normal ones that has much more accuracy fluctuations, and then the lowest one is like 0.43. Yes, and then so it shows that here is that it have 18 combination of alpha and beta, and also shows that the stable one is outperforming than the normal one in the 11 combinations, and then both perform equally is in 6 combinations, and the stable ones underperformance in only 1 combinations. And here's we apply the normal model to other real-world data sets. We can see that probably the stable accuracy is also higher than the normal accuracy. So our conclusion is that the stable Naive models can improve the prediction accuracies on the real data sets, and then when the data set sample size is small. And also we announced that we can use everyone to use the stable distributions in a Naive Bayes classifier because it's very easy to use. We just need to like integrate the R packages. That's all.